So when I submitted this to CFP for the conference, I really went for something that's very special to me. Visual reasoning and mental maps, how it's connected to me and how I am very emotional about this topic. Actually, I started as an architect. Like I just moved to software development like 6-7 years ago, and before that I worked 10 years as an architect, not a software architect, just to make it clear, a real architect. So talking about buildings. So, and I was always very visual, and whenever I came to the problem that I had to help someone to understand that what is happening, why Elixir Erlang is so special, what is the big fuss about concurrency itself, how can you make it more approachable, because to be honest, I tried many times, but there is a very big gap into get the first steps into the platform. So, some definitions. Visual reasoning, I would call this one that when you have like kind of complexity of information, that amount of complexity, that amount of information that we as a human being we are not fit to the problem. We are not good enough to understand the whole system itself. If we are talking about an Erlang application or an Elixir application, so many things are happening inside that we usually go for just to make simple assertions about what it's actually doing. This is why we write tests. This is how we set up the tooling around our software. But the question is, can we somehow bring it a little bit closer to the intuition? So mental maps, that's the metaphor I try to follow here. It's not mind maps. Mind maps, I think all of you are familiar with mind maps when you are just trying to prepare for a topic and you first try to figure out the main points and then set up connection between the ideas. Mental maps, on the other hand, is something that's coming from architecture and especially urban planning. It's about the way how human being, if it faces with a special complexity, that means that just think through that if I would ask you the question that, hey, we are now in Barcelona, how can I get to Sagrada de Familia? And all of you have like quite a big like maps inside you, but how you can give me the actual instruction how to get there, that's the mental maps. That's mental maps where how your mind digests all that complexity, and with the richness of information, you get something like this. What's interesting here that this is, for example, a mental map driven drawn about San Francisco Bay. So you can see that it already has, like if you want to find your way in San Francisco, that's already quite a big help. The interesting thing here that I want to pinpoint that it doesn't seem to be simple. So it's not about just removing all the information and get to just like simple lines. It always helps if you can see that that must be the sea, that must be a bridge, that looks like a bridge. So bringing down something complex to a simpler one is not about removing information, it's about organizing information in that sense that it helps your understanding. Just another example, this is the subway map of Barcelona. Whenever you are looking at the map like that, it's always not the case that the distance between each of the stations is not the actual distance. It only gets that minimal amount of information, but still very rich visually, so you need to spend some time to understand it. So, as I said, I submitted this CFP like 3 months ago, and the interesting thing is that I proposed to create a tool, a proof of concept to somehow investigate this topic. And like in the last 2 or 3 months, while I was preparing, already 2 or 3 new tools emerged. And I started to think about that, is it something that's actually happening? Is it now that we will move away from like all the terminal-based tracing that we used to, and now we will get that kind of developer UX that Elixir is so famous about? So first, let me give you a very quick competitive analysis that's what's already out there. visualixir, I don't know how many are familiar with it. It's actually something written like 2 years ago, and actually I started to work with Elixir 2 years ago. So it was the first thing that I ever helped me to get familiar with the internal workings of the beam. This is just a small extract from some visualixir. What you can see here, that it visualizes the supervision tree. You can get some kind of visual differentiation between the types of the processes. Also, it's possible to do some actual message tracing with visualixir. So you can select some processes and say that, okay, now I want to catch every message that's going back and through between the processes. Also, a very interesting tool that visualixir brought to the picture is this sequence diagram, message sequence diagram. So at that time when I first met with this tool, I was really falling in love with it. But after some point, I realized that it doesn't really help me in the actual development that I need to do. So it's very nice tool, it's looking awesome, but there are so many limitations that blocks me to use it when I'm developing my own software. The next tool that I want to highlight is the Erlang Performance Lab. It's created by Erlang solution people, as far as I know. And what they decided to do is to apply Netflix intuition engineering principles to the beam. Intuition engineering is about that nowadays we are facing with such complexity on software that it's not the actual quantities that we are interested in. It's more about that tools that helps us to identify patterns. For example, at Netflix used this intuition engineering tool. This is called Visceral, and Erlang Performance Lab people decided to try to adapt Visceral to the beam. What you can see here is visualization of a distributed system that has several nodes, and it's not the actual messages that are going back and through that you are interested in. It's not the actual count. It's just the rate of message passing between each system, and it helps you to investigate such topics like if you set up a load balancing scenario, and you can check that if that happens in your system, does it really work like that? So make all these things visual. They also went one step forward, and this is also the application of Visceral into processes inside a node. And you can also use it to figure out some message passing patterns that might pinpoint a problem or just helps you to better understand OTP concepts. But what they've done already in the last 2-3 months is just the rate of the messages going. They also have something very close to visualixir, showing the supervision tree. And in that sense, it's very promising because they base the whole thing on WebGL. So this visualixir is based on SVG. It's implemented by the D3 library that obviously has its limitations. This one still not that good as visualixir, but the thing that is based on WebGL, maybe it will open up some other possibilities later. So, after I researched the already existing tools, that I decided to, let's try to write something on my own. Let's try to extend the existing tools. And that's where I came up with a tool that helps to like spy on actors. And that's why I came up with the name Paparazzi. And the first thing that I wanted to try, I wanted to be brave and see things that nobody else seen before visualized. And the supervision tree is something that's very important for us because concurrency itself is built on top of supervision. So that's the tool that I created. Actually, I based it on visualixir, so I also used the D3 library because for just prototyping information visualization issues, D3 is like unbeatable. What you can see in this tool and I will also show it in live. This is some screen captures that I decided that I want to put all that many information to the actual diagram that can fit. And that's how you can see on the left-hand side that there are many kind of visualization that can be applied and toggled. And I also decided that I should make it as interactive as possible. What you can see here, that I felt the need that I should supervision itself, because visualixir, all the node visualizers before, they all just cared about showing the links between the processes. But that's not the whole story. So it's very important to differentiate, for example, that here all the red nodes are supervisors. Okay? And I also use different colors for the different types of processes. So if it's a gen server, like you can see the search child, first child, second child, they are gen servers, and there is one supervisor that supervises all these children. And what I decided to do to extract, because all this information actually is very easy to extract through tracing and through all the DevOps libraries that are already available for the Beam. So it was kind of easy to extract the actual supervision that's happening. Also, that kind of restart strategy that's applied to that very specific supervisor. I use some magic here just to be easily to fit in the picture. So, for example, RF1 means this is the rest for one restart and supervision strategy. Also, the numbers, I decided to include the index of each children into the supervision. That's where you can see by 1, 2, 3, because like for the rest, for one restart strategy, it really counts that, and when you build your system, it can be a very crucial thing that you need to make a differentiation that in which order should your processes start. Okay, let me restart this animation again. So what you are seeing now, that I also made it interactive. Like if you go to Observer, it's also possible just to randomly kill processes, but I find it much more fun to kill processes on live and see that how the system actually reacts. And how to make it happen, I need to come up with something that helps to remove one more dimension that really blocks us humans to understand concurrency issues, and it's the time. I was really thinking that should I create something like a time machine that records all the messages, all the events that's happening, and then just get a timeline and travel back and forth and see the actual state that the virtual machine is in. But I went for a different approach, and I actually just kept everything on the screen. So if a process dies, I don't remove it. If a link is not there anymore, I don't remove it. I keep it on the picture, and I can decide with this tool that what are the time frames that I can that use that kind of information. And in the animation, what you've seen, that it shows that if in a REST-for-1 strategy, if I kill or send the exit signal, that sounds not so scary. The second child, then basically, if the third child and then all the third child get restarted, and I update the supervisor. If it's the second child, then every process that started after and supervised by the supervisor will be restarted. Okay. So let me talk about visual superposition. Maybe you know superposition from physics and mathematics. That's about that if you get one set of data and another set of data and you put it together, it will be even more than just the pure sum of these data. And visual superposition is also a very interesting concept in information visualization that goes to how to build up layers of visuals that in the end leads to something that's more understandable. What you can see here is just the links. This is how the already existing visualization platforms look like. Okay, and that's how I extended it to add one more layer with the supervisors, and even add one more layer by including the supervision strategy. You can see one foray here. What we are looking at now is just a very simple applications. If you start an IEX, this is the application like the kernel that's already get started. And actually it's super fun to play with it, to see how that core system is implemented by means of concurrency. Okay. So one other feature that I was playing with, this contextual message tracing. Contextual message tracing is about that I also wanted to implement and make use of, because Erlang 19 changed a lot, and it actually introduced a new tracing, a very performant rewrite of the tracing system. It also supports LTTNG, so now it opens up that we can, with very, of course, not in a production system, set up tracing for everything happening inside the beam, and then make some reasoning about it. But also the message passing is very hard to understand because too many things is happening. And that's why I came up with the idea that what if I just use the amount of information going back and through and show it in every pair of process. Also, I come up with the idea that it would be very nice. What you see here is a very simple application. This is the usual ping pong that many of us implement. Two processes talking to each other. The first one sends a ping and the other one sends a pong. And I implemented that if I click on the number of messages that was transferred between, I can see the actual messages that was transferred. Okay, it's much more. Let me show you a live example of this tool. So it has the very similar concept that visualixir uses. It actually extracts all the process information, the hierarchies between them, and then uses these three force layout to lay out in that ways that it always looks nice, or at least it tries to do. Okay? So this is everything that I already talked about, that how I can just layer and choose what are the things that I'm interested about, what are the things that I want to see. If I start message tracing, and hopefully it will work. So you can see that's the ping pong that I shown before. So it's like in every second a ping and the pong goes back and forth, and I can extract from the backend system that what was the messages that actually happened. There was a big challenge here because it was very easy to kill Chrome itself. So because I used like WebSocket connection and pushing every message that was happening. And I had to implement kind of rate limiting that also wanted to make some kind of back pressure, but back pressure is not so easy if you want to include the browser. So I'm actually collecting all the information and only send it like every 100 milliseconds. That means that I can also see things that happening more frequently. One fun thing to do, and I just try to is so that's the system running on the right hand side, the ping pong that we actually observing. So what you can see here, and that actually it leads to the challenges that we are facing with information visualization, is scalability itself. So scalability is not just about making our system scale to the users. There is also something like scalability in this kind of developer UX. How can we make such a system that it will be able to get useful information for an actual running system? Because you need to know that all that we are doing here is just a very basic system, nothing is running, it's not an actual application, and there is no load on it. So that's the biggest question, and that's why I came up with this aggregated information, and also to put it in the system on the diagram. But that is still something that's ahead. Okay. So that got me to the key learnings that I had. I already mentioned this scalability issue. I digged very deep into all the technical details, that how can I make the tracing itself to care about all the messages that are going back and through, but still what I feel that it's more like a UX issue to solve this, that how to make that approachable. So my future plans with this one was more like a conversation starter, because I know that many people are already doing a lot of things in this topic. So I actually wanted to propose it and to see that if it takes a very simple approach to the maximum, it can already lead us to a much better understanding. So personally, I plan to contribute more on the Erlang Performance Lab, because that's where I see that the future is. That's the system that will become the next observer for us. So I haven't pushed already this system, but I will do in the coming hours, I promise. One big disclaimer here that I'm pretty good at Elixir, Elm, but not at JavaScript. So when I proposed this talk for the conference, I had this feeling that, okay, I will spend like a very good 3 months in learning more about Erlang, the Beam itself, but then I find myself just coding JavaScript for the last 2 months. So, but still, I think for a prototype, it's quite neat, so it's kind of extendable. Feel free to have a look at it. Thank you very much.
Where's the other one? So we're going to do some questions real quick. There it is. Did that run out of batteries?
Yes.
I see. Well, it's going to be a bit of a marathon for me then, but it'll work out. We're just going to have you ask the question, and I'll run the microphone up to him, and he can answer. All right, let's see some hands. Awesome.
I have a couple of questions from a user experience point of view, since you're an architect after all. First of all, is this kind like a mind map thing a little disturbing for the mind? I mean, if you see as the observer does in Erlang, the observer thing, the layered tree when you can see level by level, isn't that like a sequence kind of seeing more approachable than this? Because if you see like a lot of, I know that you have like comments, something for disturbing the nodes, but it's for the eye, you cannot find where it starts, when it ends, and it's a tree after all. And my second question, would be about the dead nodes and everything. That concept is great. It's more of a suggestion. If you can do the message passing something like a gradient behind the link, so you can normalize after a while. What I mean is, if you're sending like million messages between 2 nodes and 2 messages between other 2 nodes, I don't know, to normalize the gradient and to have like an all-time picture of how often messages are sent throughout the system, as you have with the dead nodes. Other thing with the dead nodes, my opinion, the dead nodes which are not resurrected, make them like you did, and dead nodes which are resurrected to be like stacked upon or something like that.
So the first question was, do you think that the tree view is the best way to visualize it? All right.
Okay, so I also had this idea in the beginning, but the thing is actually it's called supervision tree, but it's not a tree. So if you think about that, what all the things that adds up to the concurrency is not just the links, but and the monitors and the trap exit, all these things. And when I visualized first of it, I felt that making it more dynamic and using this force layout of these 3 will be more flexible in the long run. So that's why I went for this kind of visualization. Of course, some kinds of filtering, what are the, like, it's not needed to see the kernel itself. So if you have your own application that you are actually investigating, you don't need to see a lot of application, a lot of processes. So some kind of smart filtering will clean the canvas.
His second thing were 2 recommendations. One was like adding gradients to show traffic, and then stacking instead of respawning the dead node.
Stacking is a very good idea. What I had in mind, and I actually haven't shown it, that I just have a button that I quickly can clear the picture. So if I already checked something, I had an idea that I want to recheck that. If I kill this process, what happens, and I can look around what just happened, and then just clear that kind of buffer and remove the dead processes. And then it won't be there just in a very specific amount of time.
While we're in the habit of suggesting features, you should do like a heat map to show the traffic. That would be pretty cool, right? All right, any other questions?
Yeah, is there a big overhead for monitoring this sort of thing? Like, could you use this in production, or do you intend this to be like just a dev-only tool?
I think it's a dev-only tool.
Okay.
So every approach like this is more about, like, if you have an understanding of your system, and actually I will be very honest, I learned a lot when I created this tool, because I saw that, okay, I will implement this and let's just send a message to this one or kill this one and what will happen. And I had something in mind, and it actually was a lot of learning. So you can read a lot of blog posts, but on the other hand, seeing something before your eyes really helps. And that's where I target this tool, not to production usage.
Okay, cool, thank you.
So I actually had a question. When you developed your app, I imagine there's basically two portions, right? There's a portion which looks at the app and then gets all the information about the processes and the communications, and then there's the portion which actually renders that information. How intertwined are those two, or could they be interchangeable? Like you could create a separate rendering thing, or possibly even go for like a 3D approach to rendering using like a desktop application?
Well, the code is kind of coupled right now, because the thing is that there is just a very good book just published, the Beam internals on GitHub. And I read through that. If I'm interested in something, a very raw concept, I get actually very raw data. And to level up to our understanding, to our abstraction, I need to make the code a little bit coupled, and it's actually full with like some magic that it should be very easy to like extract like and check a GenStage and Flow implemented, that how does it really work in that one. But you need to dig deeper into process dictionary to get the actual information. And that's why now the code is kind of very coupled. It would be very hard to make it extendable, easily extendable. That's what I feel.
Thank you. I was looking forward to looking at your code too to see how you did it. I think we have time for one more question.
I just want to ask you about your visual design choices. Were you inspired by the London Metro map? And secondly, what is the meaning of animation in your design? Is it just to draw the attention of the user to things that have changed?
So yes, the previous version was not like a Metro map, but I give a very shortened version of this talk, and there were many people from London, and they already very intrigued to see the London Metro map. And because it's a very, the concept itself, the mental maps, and how the London Metro map is designed to get just the most important part of the information, but still it's very rich. That's why I wanted to apply, and that's why I went for this metaphor.
And the animations, what do you intend for them to signify in the design? Is it just to draw someone's attention to what's happening, to new things?
Okay. I think so the animation, that's what's happening. What I just recorded, that was my intention. So actually I plan to create like more use cases, that how this tool can be applied to actual use cases, but I haven't get to the point, so I really stuck with like a veterinary horse. So like an application that has all the kind of diseases that can exist. And I haven't really had the time to jump into actual software and to investigate that one. So
Thanks.
I'm in that phase right
Thank
now.
you.
All right, one more round of applause, please.